Hey everybody, this is Mr. Mott again. Gonna go over a lab we just recently did called Up, Up, and Away. It's a limiting and excess reactant lab, which allows you to kind of qualitatively and quantitatively understand what happens with limiting and excess reactants. So what I've got in here is in each test tube, I've got 10 mLs of vinegar. Okay, and you can see we got equal amounts. We controlled the amount of vinegar in there, and then the masses here on the bottom, we can see we've got represent the amount of baking soda that we put in each of these balloons. So we can see in test tube number 1 that we've got 0.18 grams, and you have to trust me, that's in there. And then 0.35 grams in this one, 0.7 and 1.4 grams. So we've increased the amount of baking soda that we have in each test tube. So as you may know, when you mix vinegar and baking soda, you make some gases. So you get carbon dioxide gas and water vapor as gas. So let's go ahead and get those mixing, and we'll talk about what we can learn from it and what happens here. So I just try to invert the test tubes there to try to make sure all the baking soda that's inside that test tube is reacting there. So I'm just going to do that again, and you kind of see sometimes the baking soda does get stuck in there. And what we want to know basically is by the amount of gas that's produced, we will be able to figure out what our limiting, what our excess reactant is. Okay. And this is a kind of a neat lab because normally one of the reasons that reactions like this can be tough is that, and why the law of conservation of matter is hard to prove, is that gases tend to escape when things change form. You have a chemical reaction. If you produce a gas, then the gas is usually hard to capture. So we've capturing our products as a gas and using that to help figure out what the limiting and what the excess reactants would be. Okay, so everything is pretty much reacted as far as I can tell here. And something to think about is, in a reaction like this where you're producing a gas, how would you know if the reaction is done? So when I invert that and I mix it again, how would I know that the reaction is done? Okay, so maybe pause the video or take a couple moments to think about that. And all right, so one way we would know that the reaction is done is by looking for bubbles, because the gas is being produced. So we would see bubbles. So if the reaction is done, then we wouldn't see any more production of bubbles in there. Okay, so what we can see from the first test tube here, I'm going to call this test tube number 1. In the first test tube, this produced the smallest amount of gas, which you might expect because it has the smallest amount of our reactant, our baking soda. When we double the amount of baking soda, we double the amount of gas being produced here. And then from test tube 2 to test tube 3, again, we're doubling the amount of baking soda here. So that should probably make sense that, hey, we're doubling the amount of baking soda, so we produce double the amount of gas. Well, from test tube 3 to test tube 4, we double our baking soda again, but we don't double the amount of gas being produced. Now this is a little bit tricky, but from test tube 3 to test tube 4, these are pretty much the same size. It's never going to be perfect in terms of how they look, because sometimes the balloons form in different shapes. But pretty much what you'll notice is that these form the same amount of gas, test tube 3 and test tube 4. What we can notice in thinking about limiting and excess reactants is normally we think about how much product is being made in a reaction, and that helps us determining the limiting and excess reactants. Visually we can actually figure out what's going on in terms of limiting and excess reactants. So in test tube 4 here, I'm just going to pick this one up, and what you'll notice in test tube 4 is that there's some solid baking soda left over here on the bottom. And so what that is showing us here is that there's excess baking soda in this test tube. So when you can see it, it's very easy to identify the excess reactant. But how could we tell? How could we tell if there's excess vinegar in any of the other ones? Okay, so when we go to test tube 1 here, we can't tell just by looking in this test tube whether you have excess vinegar or not. The vinegar and the aqueous solution that's being produced are clear, colorless liquids. But we could do this in a comparative way. So what we could do is take off this balloon and add more baking soda, and that would tell us if there's excess baking soda, or excess vinegar. Because if there's excess vinegar in test tube 1, then you're going to produce more bubbles. But we've already sort of done that, because what we've done in test tube 2 is that we had the same amount of vinegar to start with, but we've doubled our baking soda. So from 0.18 to 0.35, we about doubled it. And because we made more gas in test tube 2, we knew that there's excess vinegar in test tube 1. Similarly, what we could do to test tube 2 to know if there's excess or unreacted vinegar in here, add more baking soda. Well, we've done that. In test tube 3, you started with the same amount of vinegar as you did in 2, but now we doubled the baking soda. So when we doubled the baking soda, we doubled the amount of gas being produced. So we have excess vinegar in test tube 1 and 2, and what about test tube 3? Well, if there's unreacted vinegar in here, then when we add more baking soda, you'll produce more gas. Well, that's what we've done in test tube 4, and we did not produce any more gas from test tube 3 to 4. So that tells me there's that there's not any unreacted vinegar. There's no excess vinegar here, because when you added more baking soda, as we did, then you don't produce any more gas. So in test tube 3, we don't see any baking soda in here. So, alright, it's a little bit of a shadow there. There's no excess baking soda in there, so we know that there's no excess baking soda, but we also know there's no excess vinegar, because when we added more baking soda, we did not produce any more gas. Okay? When you do your calculations and you figure out comparatively how many moles of vinegar and how many moles of baking soda are present, you'll find the exact same thing. You'll find that you have the same amount, same number of moles of vinegar as you have in baking soda here. You'll find that you have more moles of baking soda here in test tube 4 compared to vinegar. And you'll find more moles of vinegar in test tube 1 and test tube 2. So that's our limit. That's our up and away lab. It helps us quantify visually. I should say it helps us qualify visually our what we find out in our calculations. Thanks for watching.